We observe that wind turbines installed in wind farms typically have only 3 blades, and some of them are relatively small in size. This leads us to question whether adding more blades or increasing the size of the turbines could result in greater energy generation or more efficient utilization. Today, I will explain why wind turbines are the size they are and why they are designed with 3 blades. Hello, engineering enthusiasts. Recently, we received a very interesting comment. Someone asked why the blades of turbines are so thin and why there are only 3. Would they generate more energy if they were thicker or had more blades? This is a common question, and I have also wondered about it. First of all, I would like to thank Yanio for raising this question. If you also have doubts like this, leave them in the comments. This helps us create content that addresses your curiosities and maintains a direct dialogue with you. Let's get to the point. The use of wind energy dates back thousands of years, with the earliest records dating back more than 1,000 years ago in Persia. These machines have evolved from simple devices used to grind grain and pump water to the gigantic modern turbines that generate enough energy to power entire cities. Traditional wind turbines come in various shapes and models, but most follow a consistent design of 3 blades. But why 3 blades? We can compare each blade to a wrench tightening a bolt. If we increase the length of the wrench, we generate more torque, which is the force responsible for rotation. Similarly, if we use a second wrench, we can apply even more force. This principle also applies to wind turbines. So, why not add more blades or make them longer? The largest wind turbine to date is the Mingyang Smart Energy, with a total diameter of 260 meters. It has 3 blades, each 123 meters long. Despite being made of carbon fiber, each blade weighs about 54 tons. To give you an idea, the tip of the blade can reach speeds close to 70% of the speed of sound. But why not manufacture the same turbine with more or fewer blades? Let's compare the standard 3-blade design with 2- and 4-blade models, considering that all have the same blade design. We know that every engineering project considers a cost-benefit ratio, and there is an optimal point over the lifespan of the wind turbine. If we consider the production cost over the turbine's lifespan, there will be a period until the generated revenue covers the production cost, and only then will the turbine start generating profit. If we add another blade to the turbine, we increase the production cost and consequently reduce the profits. Therefore, the 3-blade design offers the best balance between energy efficiency and economic viability. We know that every engineering project takes into account a cost-benefit ratio, and there is an optimal point over the lifespan of the wind turbine. So, if we consider the production cost of wind turbines over their lifespan, we will have a time until the revenue generated by the turbine pays off the production cost, and only then does it generate actual profit. If we add another blade to the wind turbine, we increase the production cost and consequently reduce the profits. In this way, we can rule out the 4-blade design, as its main limitation is the production cost itself. This leaves us with the 2- and 3-blade designs. Interestingly, a 2-blade design can indeed match the performance of a 3-blade design. According to the Wind Energy Handbook, to achieve performance close to that of a 3-blade turbine, we would need to either increase the chord length by 50% or increase the turbine's rotation speed by 22.5%. To clarify, in the design of a wind turbine blade, the chord is the distance from the leading edge to the trailing edge. However, consider this. If I need to increase each blade of a 2-blade turbine by 50% to match the performance of a 3-blade turbine, Adding 50% to one blade and 50% to the other would be equivalent to adding 100% to the overall design. In other words, it would be like adding another blade to the turbine, so increasing the cord length wouldn't provide much of an advantage. As mentioned, another option would be to increase the blade's rotation speed by 22.5%, meaning it would need to spin faster. Turbines with two blades rotate faster in the same wind due to the reduced drag they experience. However, the fact that they spin faster isn't necessarily a positive aspect. In fact, it can be detrimental to the design. But why is this a problem? If it spins faster, wouldn't it generate more energy? Well, the design of a wind turbine takes into account several factors, with some of the key considerations being vibration, centrifugal force, and noise. A wind turbine spinning at higher speeds can generate more vibration throughout the entire system. This means that higher speeds can introduce more vibration, requiring stronger materials to withstand the stress. It's not just vibration, there's also centrifugal force to consider. Imagine tying an object to the end of a rope and spinning it. This generates a centrifugal force that pulls the object toward the center of rotation. In other words, this force creates tension in the rope to keep the object spinning, and the faster the rotation, the greater the centrifugal force. The same principle applies to wind turbines. If we increase the rotation speed, we increase the centrifugal force, meaning both the blades and their connections to the rotor shaft need to be much stronger to withstand this force. And guess what? This increases the cost. Finally, there's the issue of noise. For those who don't live near wind turbines, this might not seem like a significant problem, but believe me, it's a real issue. A blade spinning faster will generate more noise. This is what a turbine sounds like up close. We've already made a video discussing the disadvantages of wind turbines, and noise is one of them. I'll leave a card for that video at the end of this one. After this analysis, we arrive at an optimal point with a three-blade design. They can generate more energy at slower speeds compared to a two-blade design and offer a better cost-benefit ratio than a four-blade design. This is why we typically see wind turbines with only three blades. As for their size, it has a direct relationship with production costs. The blades are designed to have an optimal size that maximizes the amount of energy captured from the wind, while considering material strength and the structural limits of the tower. If the blades were larger, the additional weight could overload the turbine's components and increase the risk of mechanical failures. Moreover, it would also be necessary to have stronger towers and much more expensive foundations, which increases both construction and maintenance costs. The saying, 1 is not enough, 2 is good, 3 is too much, doesn't apply to wind turbines. Perhaps it's time to create a new saying. 2 is suboptimal, 3 is ideal, and 4 is just too costly. If you've made it this far and enjoyed the video, consider subscribing if you haven't already, leave a like, and turn on notification bells so you don't miss any updates. If you find our content interesting, think about becoming a member to support us in continuing to produce content on this platform and stay featured in our videos. If you're looking to advance professionally, I'll leave a link below where you can discover numerous opportunities to develop skills that will make a difference in both your personal and professional life. So, did you know why wind turbines have 3 blades? Have you ever imagined having a version small enough to install on your roof to generate energy? Have you seen one of these turbines up close? Let me know in the comments. I'd love to hear from you. Over here, there are 2 fascinating video options you should watch to broaden your knowledge and satisfy your curiosity. And if you'd like to support us, Give the video a thumbs up, subscribe to the channel, activate the bell icon, and consider becoming a member. That's it for now, engineering enthusiasts. Big hug, and I'll see you in the next video.